Okay, we're going to take a look at periodic trends or periodicity. This will help us as we move into bonding for our next unit. Some of this is going to be a review from the beginning of the school year. There's some new information in here, but we need to make sure that we have all of our terms straight. For groups, these are vertical columns on the periodic table. They're also known as families. These elements will all have the same number of valence electrons. Your valence electrons are electrons in the outer energy ring. So if they're in the elements in the same group, they'll have the same number of valence electrons, which is why they'll have similar chemical and physical properties. Periods, remember, go horizontally across the periodic table. It indicates the number of energy rings or shells. Elements within the same period will have the same number of shells or energy rings. Periodicity, regular variations or patterns of properties with increasing atomic mass. Both chemical and physical properties vary in a periodic or repeating pattern across the period. Okay, throughout this video, I'm going to ask you to pause and answer some questions. All of the questions within this video we will go over during our next class. But at this time, if you would please pause the video and answer these 3 questions. Okay, here are 3 additional questions that I would like you to answer. Please go ahead and pause the video, answer the 3 questions. Again, we will go over them during our next class. This is an example of how a periodic table is numbered. This one that you're looking at happens to grow group 1, group 2, group 3, 4, 5, 6, 7, and then your noble gases are 0 or 8. And then you have your transition elements down here. You've got lanthanide here and then actinide here. Sometimes they're numbered 1 through 18. I believe the one that's in your reference folder goes group 1, 2, and then it drops down to 3, continuing across to where you would end with group 18. Other periodic tables use an A and B system, but again, for our class, we're using the one numbered 1 through 18. Your valence electrons, they're the electrons that you find in the outer energy ring. The valence electrons are the electrons that are going to be involved in bonding. Elements would like to have a stable octet, which is 8 electrons in that outer energy ring. The exceptions is hydrogen and helium. Remember, hydrogen and helium only have one energy ring, and that one energy ring can only hold 2 electrons. Therefore, helium is very happy with its 2 electrons. It is stable. And then hydrogen's goal is to be like helium, to have those 2 electrons. This periodic table is showing you your valence electrons. If you look at group 1, they have 1 valence electron. Group 2, all of these elements have 2 valence electrons. Jump over to group 3 or 13. There are 3 valence electrons. Group 4 or 14 has 4 valence electrons. Group 5 or 15 has 5 valence electrons. Group 6 or 16 has 6 valence electrons. Group 7 or 17 has 7 valence electrons. And then group 8, with the exception of helium, the rest of the elements would have 8 valence electrons. Remember, helium only has 2 valence electrons. There's only 1 energy ring. That first energy ring can only hold 2 electrons. For practice again, I would like you to pause the video using your periodic table, determine the number of valence electrons that these elements have, and then answer the question here, please. This is just a quick review to show you where your metals, nonmetals, and metalloids fall. You have your metals, and then don't forget the ones down here, your nonmetals, including hydrogen, and then our metalloids separate the 2. There are specific names for some of the groups. This first group is also known as the alkali metals. Group 2 are known as the alkali earth metals. Your transition elements or transition metals are the box that's inserted, group 3 to 12. Group 7 or 17 are known as halogens. Group 18 or 8 is known as our noble gases. And then again, we have our lanthanides and actinides. Again, here I would like you to pause the video and answer these questions. Again, we will go over them during our next class. Okay, taking a look at the properties for metals. Your metals tend to give up electrons to form a cation. If you give up electrons and make a cation, you're going to become positively charged. Remember, the T in cation is representing the positive sign. They have low ionization energies. Ionization energy is the energy required to remove an electron from an atom in its ground state. The electrons that are the most metallic, the lower left hand, if you were to go down at the lower left hand corner, they have the lowest ionization energies. This IE represents ionization energies. Your metals tend to have 3 or fewer electrons in their outer energy ring. They are malleable, meaning they can be bent or hammered into different shapes. They're ductile, meaning they could be pulled into thin wires, and they're good conductors of electricity. Your nonmetals tend to gain electrons, forming an anion. Anions are going to be your negative ions. They have a large ionization energy, and they have the highest electron affinity. Electron affinity refers to gaining electrons. Group 1, again known as our alkali metals. The alkali metals tend to lose electrons. These metals are very reactive, and then as you move down the group, the reactivity increases. So at the top of group 1, they're reactive, but then as you move down, the reactivity is going to increase. When they react with water, you are going to get a hydroxide. That OH is your hydroxide polyatomic ion that you guys are memorizing, combined with the metal. So this would be sodium hydroxide, and then hydrogen gas. And that is true when you look at group 1 and you've got your metal reacting with water. You're going to produce that metal hydroxide and then hydrogen gas. Your alkali earth metals, these are for group 2. They contain a pair of electrons. Remember, they fall into that S2. They like to lose 2 electrons, which means they would have a positive 2 charge. They're harder and denser and stronger than the alkali metals, but they're less reactive. Your transition elements, good conductors of electricity. They have a high luster, that shine to them. They are less reactive than both the alkali and alkali earth metals. You'll notice a trend that's starting there. If you think of group 1 was very reactive, group 2 is reactive but not as much. And then as you go into your transition elements, they're reactive again, but less than the alkali and alkali earth metals. So again, reactivity is starting to decrease as you move across. Your nonmetals are to the right of those metalloids. Remember, your metalloids are along that staircase. And then they are non-conductors of electricity. Okay, taking a look at the metalloids, they are brittle solids. They say they line the staircase. Some periodic tables will put a red zigzag line here. They'll call it a red zigzag or a red staircase. And then they say the elements that line that staircase are the metalloids. Some periodic tables will actually show These included, for this class, you need to know the ones in orange are the metalloids. As long as you know the one in orange, you'll be fine for this class. Okay, taking a look at the halogens, which is group 17 or group 7. Halogens react vigorously with metals to form compounds such as salts, not just table salt. Your table salt is sodium chloride. There are other examples of salt, calcium chloride, copper 2 chloride, just to name a couple. And then as you move down the group or down the family, the reactivity is going to start to decrease. Your noble gases, group 18 or group 8, they're completely stable. They're not reactive. They can react under certain conditions, but they tend not to, and that's because of that full octet that they have. Again, helium is an exception to the octet, meaning the 8 electrons in the outer shell. Helium only has one energy ring. That first energy ring holds a maximum of 2 electrons, and helium has its 2 electrons. But the other noble gases all have 8 electrons in their outer ring. Your diatomic molecules, we went over these at the beginning of the year, but you need to make sure that you have these committed to memory. Remember, diatomic molecules are molecules composed of only 2 atoms. They can either be the same or different chemical elements. The diatomic that you need to remember: hydrogen, nitrogen, chlorine, oxygen, iodine, fluorine, and bromine. I showed you guys, if you put your finger on atomic number 7 and draw the number 7, that walks you through 6 of them: nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Again, start at atomic number 7, draw the number 7, and then you need to include the hydrogen. There's also the little acronym Brignikov. This BR is for bromine, I for iodine, N for nitrogen, Cl for chlorine, H for hydrogen, O for oxygen, and F for fluorine.